I'm Elizabeth Koskin, a PhD researcher based here at the University of Southampton. My chosen research area is web science. The concept of web science was first introduced in 2006 with a paper entitled A Framework for Web Science by Berners-Lee et al. Just as computer science can be described as the science of computing, web science can also be described as the science of the web. Web science is inherently multidisciplinary, affecting virtually any area on which the web has an impact. An increasing number of institutions are now beginning to offer web science or related programs. The majority of these are currently at master's or PhD level. However, an increasing number are now also offering undergraduate programs. The aim of my work is to create an overview of web science. This will be achieved by taking the elements common to the majority of web science programs currently offered around the world. Examples of definitions that currently exist for web science include the Web Science Cluster Diagram created by Nigel Shadbolt. Another example is the Web Science Subject Categorization. This is currently the only attempt to create a formal curriculum for web science. It was created using a formal top-down theoretical-based approach. Within a rapidly evolving field such as web science, definitions created using a traditional top-down method are highly likely to become outdated by the time they are completed. In order to address this problem, research which identifies from the ground up the content and different types of teaching for web science at different academic levels can be usefully used to define the curriculum. I'll now briefly explain the difference between these two research approaches. So when using a traditional deductive or top-down approach, the researcher begins with a clear preconceived theory and then sets out to prove it. By contrast, when using an inductive or bottom-up or ground-up based approach, the researcher examines the available evidence and then develops theories based upon their observations. Because of the emerging nature of web science, it's arguably well suited to a ground-up based research approach. This method should also ensure that the final outcome is shaped by the content of the actual curriculum. My work aims to examine web science by taking a ground-up based snapshot of what is currently taught as web science in taught programs around the world, in order to answer the question, what is web science, using elements common to the web science curricula worldwide. My research began with a simple desk survey identifying institutions across the world which teach a web science or related program. I then expanded this to include individual modules for each program. The module desk survey includes the following fields: institution location, resource title, topics taught, teaching assessment format, contributors, materials used, level, for example, masters, module dates and duration. One of the key difficulties faced during this exercise was the fact that I was only able to gather data from institutions which provide public module information on their websites. Another key problem I faced was inconsistency in the data, so the fact that some universities offer, for example, specific teaching dates for their modules, whereas others will only say semester 1, semester 2, and others will omit the information altogether. Each web science course varies between university, with some courses displaying a technical bias and some with a more social science-based approach. All biases need to be considered and taken into account in order to present an accurate picture of the subject. The findings will be compared with existing definitions of web science, such as the Web Science Subject Categorization seen previously, as well as the most frequently occurring keywords found in papers taken from the web science conferences. The full results of the desk survey will be analysed using a combination of thematic analysis and keyword analysis, utilising the qualitative data analysis package NVivo. These methods will be used to pinpoint common elements between the web science curricula identified. Future work includes the ongoing search for additional data sources, one of which may include the harvesting of tweets and Twitter content relating to web science. Another desired outcome would be to recommend or provide plans for an automated method for tracking the development of the web science subject. It's hoped that this work will inspire further debate within the wider web science community, with the aim of encouraging and inspiring further work into the definition of a web science curriculum. A more accessible and widely available definition should not only encourage further participation and interest within web science, but also help promote web science as a taught subject worldwide. If you have a background in web science or a related subject, then you can contribute to this research. At the end of this video, there'll be a link to a short questionnaire-based survey, and your feedback would be greatly appreciated. Thank you for watching.